Hello, my name is Ronald Batley. Most of my students call me Ron. I'm the CNC instructor here at PTTI. I teach both welding and manufacturing students. CNC is a great addition to any resume if you're in the manufacturing or welding field. And in manufacturing, the programming that we do here acts as a great precursor for PLC programming. For the welding students, it actually gives them the ability to, you could say, automatically cut out different shapes or pipe that they might need. They're trained to use a handheld plasma cutter. This basically speeds up the process. Now, both sets of students, both manufacturing and welding, they are taught computer-aided drafting. They're taught computer-assisted management, and they're also taught how to write manual G-code. It's a pretty extensive program, and today I'm going to give a demonstration on cutting sections of pipe for the welding department. The students use these as both practice and test welds. So I'm going to run you through the process. As you can see, we've already loaded a new piece of stock pipe, and we're really big on safety here. We make sure everybody's wearing face coverings, safety glasses, steel toe boots, and anytime you're using equipment, you always want to make sure that you have an indicator like these flashing lights that these particular areas are going to be in a danger zone. Okay? All right, so the way this system works is compressed air is mixed with electricity to create plasma. Now, there has to be a complete circuit in order for the torch to cut through the material. The ideal length above the material is 3/16 of an inch. You could go an eighth, maybe up to 5/16, but you want to stay in that range. If you go outside of that range, you're not making a complete circuit and the torch will cut off. So continuity is very important. The completion of the circuit is vital in order to make proper cuts. And this mechanism is all computer controlled. Everything that we program in the computer runs through this flash cut controller and then to the different components on the machine, the servo motors on the side of the machine, the torch itself. So this is basically like the hub between the computer and the physical equipment itself. So the first thing we need to do is move the torch all the way over to where the pipe is. In order to do that, we have to make sure that our dry run is connected and that our power source is hooked up. The power source we use is a Hypertherm PowerMax 85 plasma cutter. Now the 85 actually, that is the maximum amperage of the equipment itself. It goes up to 85 amps. Very rare that you would need to cut something that high. So, in CAD, this is where we would create the drawings. In CAM, this is where we could modify the cut path, and we also generate the G codes from the drawings in this particular program. A G code, the G in G code stands for geometry. You use a series of coordinates, both X, Y, and Z, and in the case of today, W. And all your movements are basically controlled through inputting different coordinates. Once you know the series, how everything is laid out, it follows the same pattern all the way down the program, okay? But in order to make any torch movements before we get started, we need to do so in the CNC section, okay? The Z-axis is what actually controls the torch head. So we're going to move it up, and we're going to use our X-axis and move it all the way over to the right as much as possible. We have a safety lamp, and we have the measuring tape. As we said, safety first. Okay. This clamp here is the ground clamp for the drum, the W-axis. It's, like I said, it's just part of the circuit. The equipment has to be grounded, otherwise we'll get ground fault errors. We actually have to lower this torch head to the lowest possible setting. It's a magnetic breakaway system. If it were to get hung up on a piece of metal, that's a fantastic safety feature. It'll actually break away and the torch will shut off. We're going to actually angle it to 57.5. And we'll tighten this back up. One other thing that we need to do is we need to check our torch consumables. There's a series of components inside the torch head, and we want to make sure that they're not worn or damaged or out of round. The shield cap actually looks good. There's no damage, no warpage, no dents, so that's a good piece. The nozzle, the nozzle itself is still pretty round. There's not a lot of carbon buildup on the electrode. This is the electrode, okay? And this is the swirl ring. The purpose of this, it actually creates more of a tornado effect when the compressed air goes into the torch head. It allows for this nozzle will actually focus the plasma beam into a much narrower. So these consumables actually look pretty good, so we don't need to change anything out per se. I'd say on average we change them about once every 2 weeks, but it also depends on where. If we do several jobs in 1 week, we may end up changing them twice in the same week. But we put that back together, put it back on our torch head. We are going to use our Y-axis, move the torch back farther. We're going to use our Z-axis and lower it. Because the welding students actually need room for the bead for their weld, it can't be straight pieces of pipe. They have to be beveled. That way their melt has a channel all the way around the pipe. 57.5. Okay, that looks pretty good. All right. Now we have to center the torch into the center of the pipe. We're going to move Y forward a little bit. We're going to lower our Z-axis. Now when we get this low, we're going to switch to 0.1 instead of continuous. That way I can do some fine tuning. Alright, so we need to come up a tenth of an inch at a time. We're going to bring the torch up just a hair. We're going to switch it to 100 thousandths of an inch. We don't want it to be too close to the material. Alright, now we're going to set our zeros. We need to go to Machine Home, Zero All, Program Set, Zero All. This is a program to cut 5 lengths of pipe. I'll try to sum it up for you in a nutshell. I actually wrote this program at home and brought it in so I wouldn't have to repeat. G20, that's the first line of every G code. It signifies that we're using inches as our unit of measure. If we're using the metric system, it would be G10. M106H Plasma 1, that designates our power source, our PowerMax 85. Hashtag fabhead.mode equals cut. That just signifies that we're in fabrication cut mode. That's the only mode that we have on this particular piece of equipment. Okay, you identify your home position, which is X0, Y0, and we also put a W0 now since we're using an extra axis. Okay, and now there's a series of, okay, we set the torch at 0. G603, that is a code that allows for manual torch control. M50 is the code to turn the torch on. Okay, this will be our first coordinate. We're actually going to lob off the end just so we have an even piece to work with. And the speed that we're going to rotate the drum is 60 inches per minute. And I found through trial and error that seems to be the best speed. There's a standard set when you'll notice there are codes that say G00. They're automatically set at 366 inches per minute. They're rapid linear movement with the torch off. G00, the torch is off. G01, 2, or 3, the torch is on. Okay, this M51 code, that's to turn the torch off. And in between cuts from line 6, G03, to line 15, where we lower the torch back down, that's one complete cycle and it moves to the next position. It follows the same pattern all the way down. Okay, I won't get into too much detail. There'd be so much to explain. I could spend a whole day explaining each line of code. But what we're going to do now is what we call a dry run. We're going to run it with the torch off just to make sure that it operates correctly. Okay? So we'll hit play. I'm going to refresh the code. Everything's zeroed out. We are going to hit play. And we're going to watch how this plays out. Okay, so now the drum is moving in reverse, so the W axis can reset itself back to the 0 position. It has to do that after every cut. As long as the torch doesn't raise up too high, and if we're good, we will go ahead and cut these 5 pieces out. I'm going to turn this down a little bit, see if we can get through it at 70. Alright, here we go. Ready? And away we go. Roll in, drop down. So what we would do from this point, so I would take my angle grinder, and this is the impact point where the torch makes contact with the material. You're always going to get a little anomaly there. So what I do, okay, see, now what'll happen is a welding student will set these up to where they'll have this channel, and then this channel actually gives them the room for the bead they need to join these pieces together. They'll use this both in practice, joining pieces of pipe together, and they also, this is one of the tests they offer, is welding pipe. Okay. So we just went through the entire process of cutting a pipe using the CNC plasma cutter. Everything from loading the program, centering the torch, doing a dry run to make sure that the torch tip doesn't come in contact with the material. We leveled out all the pieces. We made the necessary cuts, and that pretty much wraps it up.